Today's electrical grid is seeing an ever-increasing amount of smart equipment. This increases the communications and noise on the grid. This increased noise can create measurement problems that make locating ground faults challenging. This is a fairly common issue that can be encountered when tracing a ground fault. The measured value will not stabilize. This can be due to low frequency oscillations on the line. As the frequency of the oscillation increases, the effect on the measured value decreases. As the frequency increases to 30 Hz and 40 Hz, the effects on the measured value are beginning to decrease. The noise current present on the system will flow from the source through the system and return on the neutral line. The trace signal injected by a ground fault transmitter will pass through the earth return. The fault current from the transmitter and the AC noise will both be present on the system, but they will return on different paths. If a CT is placed around a single line that contains both the fault tracing current and the noise, it will measure both. The measured value will fluctuate with the amplitude of the noise. By placing the CT around the line being measured and the system return line, the noise on the system is canceled out. This allows the receiver to only measure the tracing current going through the earth return. Another option is to use two current clamps in parallel. Place one on the return line and one on the line being measured. Each CT will measure the noise current, but that measurement will be 180 degrees out of phase, so they will cancel out and only the trace signal from the transmitter will be present. Let's look at the effects of low frequency noise on the new Megger MGFL100. We can see at a 20 Hz oscillation, we have a stable measurement. Since the MGFL100 operates at a lower frequency, it is less susceptible to low frequency noise. The MGFL100 is just using one current clamp. Even if the measured frequency on the MGFL100 does become unstable due to the system noise, this can be compensated by either placing a single clamp around both the line being measured and the neutral line, or by using a second current clamp. We can see by using a second current clamp, the system noise is canceled out, allowing the MGFL100 to display a stable measurement of the tracing current. The low frequency operation of the MGFL100 allows the unit to operate under this noise floor. The MGFL100 also provides a means to cancel out any low frequency system noise that may exist. This greatly simplifies the process of ground fault location.